There used to be a time when weather conditions were simpler. Hardly did they affect our daily activities. But is that still the same today? Is our weather becoming more extreme? And if it is, why? Is climate change really to blame? In this video, we will look at some key concepts, such as what extreme weather is, its types, and its possible connection to climate change. So, stay till the end to fully understand the video. First of all, let us fully understand what extreme weather means. According to Wikipedia, extreme weather includes unexpected, unusual, severe, or unseasonal weather at the extremes of the historical distribution, which is the range that has been seen in the past. This basically means that if there is anything off-season or something odd about the state of the atmosphere, it can be summed up as extreme weather. Extreme weather events are generally unexpected, but when they do occur, they can be quite damaging. Take for example Hurricane Maria, an extremely powerful and deadly Category 5 Atlantic hurricane that affected the Northeast Caribbean in September 2017, resulting in the deaths of 3,059 people and damages amounting to $91.6 billion. There are countless examples of these extreme weather events and their impact on human lives and properties. Now that we understand what extreme weather is, we must learn about its types. There are many types of extreme weather, including heat waves, cold waves, heavy rain, or storm-like situations. The effect of these extreme weather events largely depend on the area where they happen, the type of extreme weather, and the population size. The most common impact of these weather events is the ability to cause greater economic losses and cost human lives. This is why it is important to understand what causes these events to occur in the first place. Heat waves. A heat wave is an unusually hot weather event in which a certain area experiences high temperature and high humidity that can last for several days. During this period, the normal temperature of the area are higher compared to the usual temperatures for that particular season. Heat waves are typically caused by high-pressure systems that trap hot air in an area, preventing it from escaping. This phenomenon occurs when atmospheric pressure builds up, creating a sinking column of air that compresses and heats up, often leading to a prolonged periods of unusually high temperatures. The dangers associated with such events occur when the wet bulb limit exceeds 35 degrees Celsius. Humans lose their cooling ability through sweating, as at higher temperature and humidity, sweating does little to help, reducing our ability to cool ourselves and leading to dangerous situations like heat stroke and other heat-related illnesses. There have been several incidents of heat waves this year. For example, in India, according to Health Ministry data provided to the Associated Press, between March 1st and June 18, around 110 people lost their lives after suffering from heat strokes. The Mexican government has registered 155 deaths related to high temperatures since March of this year. Between June 14 and 19, at least 1,300 people died due to extreme heat during the Hajj pilgrimage in Mecca, with temperatures exceeding 50 degrees Celsius or 122 degrees Fahrenheit. Many lost their lives due to heat stroke or dehydration or both. It is important to note that heat waves become more intense in urban areas as opposed to areas with more trees and plants, due to an effect called the urban heat island effect, which is more evident in cities with limited greenery and more buildings and asphalt roads. Another factor influencing heat wave is the El Niño effect. This phenomenon is more prominent in the Pacific Ocean, but it has the potential to affect weather worldwide. Now moving on to the next point. Cold waves. Cold waves occur when the polar jet stream, the winter jet streams running between the boundary of Arctic air and temperate air, moves southwards. This brings cold Arctic air to areas where such events do not frequently occur. The southward push of the polar jet stream is generally associated with a weakened stratospheric polar vortex. A stratospheric polar vortex is a large stream of air moving around the North Pole in the middle of the stratosphere. When the polar vortex weakens, it can split and influence the jet stream to move southward. Another factor affecting cold wave is the La Nina effect, which is more prominent in the Pacific Ocean but can affect weather worldwide. Interestingly, there can be several origins for cold waves based on the geography of the area. In North America, cold waves often originate from the Arctic or northern Canada and can result in frigid temperatures across the United States and Canada. Notable examples include the North American cold waves of the year 2014 and the polar vortex events of year 2019. In Europe, cold waves are typically caused by the displacement of cold air from Arctic or Siberia. For example, the Great Frost of year 1709 brought unprecedented cold to the continent, causing widespread crop failure and famine. Asia experiences a diverse range of cold waves, from the chilling Siberian Express that affects countries like Russia, China, and Japan, to the cold snaps in South Asia, which can cause severe agricultural losses in countries like India and Bangladesh. In Australia and Oceania, although cold waves are not that common, they can still bring snow to the highlands and unusually cold temperatures to the coastal areas, as seen in the 2011 New Zealand snowstorm. Cold waves can pose significant health risks, including hypothermia, frostbite, and an increased likelihood of respiratory and cardiovascular illnesses. Now that we have discussed cold wave, it is important to mention the next ever extreme weather, which consists mostly of storm-like situations. Tropical cyclones. A tropical cyclone is a rapidly rotating storm system with a low pressure center, a closed low-level atmospheric circulation, strong winds, and a spiral arrangement of thunderstorms that produce heavy rain and sharp increase in wind speed, also called squalls. They can have various names based on their location and strength. If they occur in Atlantic or northeastern Pacific Ocean, they are called hurricanes. In the northwestern Pacific Ocean, they are called typhoons. In the Indian Ocean and South Pacific, they are referred to as tropical cyclones. Tropical cyclones typically form over large bodies of relatively warm water, deriving their energy from the evaporation of water from the ocean surface, which ultimately condenses into clouds. It rains when the moist air rises and cools to saturation. Tropical cyclones regularly affect the coastlines of most of the Earth's major bodies of water along the Atlantic, Pacific, and Indian Oceans. They have caused significant destruction and loss of human lives, resulting in about 2 million deaths since the 19th century. Now that we have discussed all the types of extreme weather, it is time to move on to the next part. Does climate change have anything to do with the increase in these extreme weather events? Firstly, it is important to know that weather events like these are very complex and occur due to several reasons, including natural variations. Therefore, trying to associate these events with only one cause means ignoring the role of other factors. Regardless, scientists are trying to understand the impact of climate change with respect to the increase in the intensity of extreme weather. Exactly how? Well, scientists use data and input it into computer models, also called climate modeling, which simulate hypothetical scenarios. This is also referred to as Attribution Science, the study of the relationship between climate change and weather events. By now, you must have at least heard about global warming and how we contribute to it. This primarily comes from emission of greenhouse gases, which can originate from various sources, both direct and indirect. Regardless of the origins, greenhouse gases have the potential to warm our atmosphere by trapping heat that escapes from our planet. According to Stephen Ramstorff, a professor of physics of the oceans at Potsdam University, air can hold 7% more moisture for every degree rise in temperature, which can be proven by applying the Clausius-Clapeyron equation, stating that vapor pressure is directly related to the rise in temperature. It is also important to note that saturation of water vapor is positively related to an increase in temperature. This means that a general increase in global temperature can influence oceanic temperatures, leading to an increase in the frequency of tropical storms. Furthermore, rising global temperatures can make heat waves more extreme. In conclusion, it can be said that climate change is affecting the intensity of extreme weather events. Although the occurrence of particular weather events can have several factors behind it, it is important to build plans to find solutions to help save our communities from potential losses. Apart from this, we should respect our surrounding nature more often than we think we should. Our Earth is our home. We have a responsibility to keep it livable and clean. With that said, thank you for watching.